Good. I think most everyone is familiar with us here. Nestor is going to give a talk today about Docker. And thank you all for coming. As always, we know that many of you are happily employed, and that's good. We're always looking for new people. Talk to me. And let's get going. Thank you.
Sit. Yes, please sit.
Or we'll choose.
Hi, I'll be giving an introduction on Docker. I'm new to this, so
Come on.
I'd like to share what I've learned for so far.
I missed this.
By the way, these are not my slides. I borrowed them from .cloud, the creators of Docker. They're nice enough to put them online. So. It's an active project. It's currently 0.6.6, and as of September, these are their stats. Around 4,000 GitHub stars. So, why all the excitement? It solves a certain problem deploying server-based applications. Back in the day, you have what we refer to as a monolithic stack, web server, database, well-defined tiers. But now it's not the case, or it's starting to be more fragmented and more complex. You use queues, you'll use APIs, and they're all over the network. And they can run on any hardware. It can run on cloud. It can run on bare metal. And while building these blocks, the problem is how do you ensure that these parts still work? How do you, they call this the n-by-n problem, wherein one dimension is the how complex the stack is, and the other dimension is how do you, the different environments that you deploy it. And how do you ensure that when you migrate or when you scale out, how do you ensure that it's still working, the parts are still working? So this is an example. So you have a front end, you have workers, connect to an analytics DB like MongoDB. You have endpoints, environments. They could be as simple as your development machines. Right now we have, for instance, we have two iMacs and we have laptops. For our project, we run Vagrant and we provision the images, the VMs through Chef. But sometimes, yeah, you still need to push them or push your code to a staging server. Then there's this other server that serves as a demo server, and eventually, when things are going well, onto production. And you just wish that things don't break as your code gets promoted to production. This is n by n. So, how do you deploy your stack on the VM? Our Chef recipes we built them from the ground, and these are not the same recipes as running in production. Yeah, we had to solve a pain of having to rebuild and stuff and get to work. So yeah, in the real world, there used to be a problem of how do you transport goods from point A to point B. Back in the day, if you're shipping, say, coffee from one point, you'll have to worry about, is this coffee, if I put them on the truck, how do I package it? when it gets to my intended destination, the people who will unload the truck, do they know how to unload it, and so on. So the number of goods times the number of modes of transportation, that used to be a problem, but with the introduction of the, what's an end by end problem? The introduction of a container, it's now an abstraction. So if I'm sending stuff, I just put them inside a container. I tell the truck knows how to load the container. It does what it's supposed to do. It goes to the destination. People on that site know how to unload it. If it needs to go on a boat, then or be lifted on a crane, people who can operate. Basically, it's standard. It's standard now. And it led to a lot of advantages. You don't have to worry about how certain things are stored.
Explosion in global trade.
Yeah. So, wow, 90% of all cargo is now shipped on a standard container.
Wait, can you go back?
Yeah.
This says an order of magnitude reduction in cost to time to unload and unload ship.
So once you build this,
losses
it's-
due to theft, yeah, it's a huge benefit. Right.
Yep. So Docker is like that. It acts as a shipping container where the goods is your stuff, your code. Docker exposes a standard interface that you can use to, say, pull an image. So I'm using terms like containers and image, and hopefully I'll be able to explain them adequately. So it's what they call a container engine. It runs, it's like a substrate. It runs on the lower the OS, then the Docker engine, then your containers. When you're pushing code to another server or to another cluster, that cluster runs Docker. It knows how to operate your container. Container is simply your code plus its dependencies. So you don't ship like a directory or a jar file. It's jar file plus whatever it is it's needed, like runtime. There are libs, then that gets included.
If you're using a database, does the database go in the container?
Yeah. But I think there's still work with regards to mounting external volumes.
Okay.
But
Or it could connect to a database.
yes.
As a service.
Mhm. So why does it matter? It's content agnostic. It doesn't care. A Docker doesn't care what's inside. As long as it gets shipped in a container, it can work with it. It's hardware agnostic, but you need something like LXC. That's the Linux container extension. It provides isolation such that a process has its own sandbox, like a file. Think of it as when your phone, each app has its own space, like a jail. It's actually a jail. Yeah, LXCs are jails. It provides automation, standard ways of starting, stopping, pulling, pushing. So with regards to efficiency, one difference between a virtual machine and the container is that the container doesn't contain the whole operating system stack. It shares the operating system with the container engine. And we can now have separation of concerns, so that the developer doesn't have to do more ops duties, or the operations doesn't have to know how a certain RVM doesn't get installed, and so on.
So conceptually, this is the same as VMware. Conceptually.
Conceptually,
But it's implemented in a lightweight manner using Linux containers.
This is more similar to FreeBSD jets, wherein you CH root to a process gets its own CH root tree.
When you build a Docker container and ship it, is it good for any platform? Like, what if the CPUs are of a different architecture or something?
Good question. I'll find out.
Well, I know
Yeah.
Docker works on ARM.
Yeah,
So-
but
Yeah, but the runtime-
are your containers like target specific? Because like if you shipped Ruby in there, right?
Yeah.
Like Ruby has to be built
Good question.
for that process, right?
It's not like Go that does cross compilation, or so maybe.
So your containers are containers for like Linux, but like
Mhm.
which Linux? All of them? All of them that support LXC?
Yeah, the basis right now is Ubuntu, and I think CentOS. Yeah. And yeah, that's 12.10. 12.10.
Okay.
Okay.
Huh. Run anywhere.
Well, they seem to be.
It says run anywhere, but
Yeah, but I take that with a grain of salt. I don't know if
That's
it,
marketing.
I,
It's
marketing.
marketing.
I
Marketing
don't know,
slides.
so I encourage you to try out.
I want to try it.
Yeah. It's still they don't. It's still an active development, and they don't encourage people to use it in production yet.
So
So
another thing I wonder is, what does it look like to the host operating system? Is it a process, like a container is running and it's a single process, or could it be a bunch of processes?
it
Like if your
Yeah.
thing has a couple of services, are they must be processes in the host operating system?
strictly speaking, there's typically one application process per container, but
Okay.
some have argued that it's possible to have something like a process tree, or something.
Okay.
You could run something like Monet, or that spawns a bunch of processes.
Okay.
I haven't tried that, but
Okay.
so far the examples have been, I have a single Rails process, and
Monet. Where is a Monet gonna?
Fit in this?
Yeah.
moving on.
Running.
So, in the DevOps world, it aims to eliminate inconsistencies between development, test, and production environments. This is harder than it looks. There are still differences, I think. Yeah, so I mentioned performance benefits of using containers versus if you're simulating a multiple tier, or say APIs and rescue and whatnot, having to put them in containers is cheaper. Or obvious example, if you're running some kind of a CI service, you can have, instead of how some do it, they have virtual machine workers, as in live VirtualBox workers. You can have something like a container and just wait for messages and build. Yeah, so I mentioned this, and this is the diagram.
These look like processes.
Mm-hmm.
Okay.
Right. Okay, moving on. Why are they lightweight? Apart from LXC, it uses a different type of files. It's called a union file system, particularly AUFS, another union file system. You're essentially working with diffs. So for example, your image is based on a particular Ubuntu base, and you've previously downloaded that base. When you pull that image for, let's say, a Rails app, it doesn't need to, and that app uses that base image somehow, it doesn't need to pull that again. And when the container boots out, it gets the union of whatever it needs.
So if it writes files to its local file system,
It's like the top layer is only writable.
it can see it, but the host OS cannot see it.
Mhm. Yeah, as far as I know.
Can you like SSH into your?
There's a way to attach to the
Container?
process.
Oh, okay.
I think that's the closest I could see, closest SSH thing that I could see. But there's an example that runs an SSH service. Then you can use that container to build your own. So theoretically, you can have more than one process, one for the SSH and the other for your application. Again, I haven't tried this, so maybe it works, maybe it doesn't. This isn't new. There's a similar way of deploying applications where you use RPMs. You basically build the application with its dependencies, put them in RPMs, shoot them in a new VM. Then once that's running, you point that DNS to that new machine. So it's kind of similar to that. But what's new here is the image registry. Now, when one thing that's different here and could be cool is that Contrib deploys as Git. They're like Git pushes. So if you use Heroku, you're just pushing to a remote, then there goes your deploy. Right. To build a container, you can do it manually, connect to a container, do your stuff, save your changes, then do Docker push to put them in the registry. Or you can have some kind of a script called the Docker file, which specifies in sequence what commands that you need for that particular container.
So does that replace like Chef for that thing? For that?
I think you can still use Chef to, let's say, make the base image. Then once you have it, in our case, we have to when you do vagrant provision, we rerun Chef, right?
Yeah.
But if you have a base image, it's like having a binary. You don't have to do it again unless you change the composition of your image. It's versatile since we're
This is kind of like what Heroku does. When you push to it, it
Yeah.
builds a, what do they call that?
they have a build pack
Okay.
that it's used with the app. Then it creates a slug. There's a project called Flynn that does it's built on Docker that aims to be an open source Heroku.
So the Docker container image registry, is it like a version control thing? I mean, like you're holding like a bunch of builds for
Yeah.
your thing?
It's like Ruby gems, and where it can
Uh-huh.
search, and it tracks the hash or the container IDs. You can also host a private registry and just point it to that particular registry. And there's an HTTP API.
Could be helpful in debugging if you want to roll back really quickly to previous version
Yeah.
and to check whether something was broken.
What it's like in the old days it's called system of record,
Yeah.
where all the changes made to that particular environment are kept like this one. So if you're not using Docker, what's the alternative? Yeah, so you can introduce policy like, okay, we're not going to use, or we're going to use this kind of queue, or we're not going to use it. Okay, we're going to have like Puppet or Chef to provision our boxes from a blank VM. We could virtualize, build it once, and save the image as a OVA or whatnot, or yeah. Going at it one by one. You can try to impose a consistent development environment, but some of us prefer Z shell, some of us just stick to Bash. So, you know, yeah, hi, hi guys. So some install fastly, some don't.
Some like RBM.
Yeah, some like RBN. So, yeah, you could have something like a Chef or Puppet to automate your provisioning, but it only gets you so far. Please sit.
Hi guys.
Yeah, hardware virtualization. We have guests from engineering here, so they know this stuff more than I do. Like, yeah. Yeah, package automation. So, there's the creator of Vagrant also released a tool called Packer. So, what it does, if you're targeting, say, VMware, so it provides the particular provisioning script for that VM. So yeah, containers complement automation. That's how that's the direction. So if you're curious, this slide is available in SlideShare. Just search for Docker and you'll find it at the first two results. And these are good examples on how Docker is being used right now. Again, it's a moving target, so don't expect things to work out of the box, or if you're trying to host an online service. And well, I'm still exploring it, so maybe we'll see, but it's pretty good stuff. Of course, not mine. Thank you.
Demo.
Yeah, sure. Yeah, so two things here.
Font size.
Yeah. So, una. Yay. So, I'm going to start. So, I'm running Docker. There's no native Mac Docker, so you have to run, ironically, a Vagrant machine. So, there's my laptop, Vagrant, and Vagrant and Docker.
Yo dog.
Docker only runs on Linux.
Linux, yes.
Font size.
Plus. Yeah, so. Talaga karapatan ng mamamayan Yeah, so. Pakasal ka muna. So Docker provides this bigger file that allows you to set up Docker runtime, and these are the commands available. I've already downloaded images, so we're going to Docker run detach ports 3000 FCAP.
It's own internal.
Yeah, so note on port mappings. So since we're basically doing an inception thing here, where there's the map, there's the Vagrant, and there's the host. So the container has a Rails app running on port 3000, I'm mapping the port 3000 to Vagrant's port 3000, which is configured to be exposed in the laptop. It's localhost 3000. Yeah. And there's the, so it's the way it's got. So, according to the author, it's DHH. BBC, DFG. And I will not create a post. So what if I have another container booted up?
Yeah, where's the database of that?
It's SQLite, so it's in the file system.
Okay.
So when I kill that,
It's wiped out.
yeah, wiped out. So I'm going to run another one. Just
Wait a second, so the union file system is volatile, like when the process goes away, that union is gone?
as far as I know, yes.
There's no persistence.
You
so
can
no
commit.
persistent
You can-
storage in the container.
You can tell the container not to detach. So keep the container alive, but
Okay.
stopped.
Oh,
So you can attach to it and save that image, that
okay.
snapshot. I'm gonna start another one. See, these hashes these are the container IDs to show which containers are running.
So you have two rails. So
Yeah.
Yeah, can you do a regular PS?
Yes. This is in the Vagrant, so
Yeah.
The host
It,
Docker.
there should be a Docker process, right? Okay,
LXC.
so one process for
Per
each
container.
process inside the Docker.
So it worries about building the .lxc file for you. It looks like it.
yes. Huh. So now back. We have a fresh app. Still there. Two. Unfortunately, yeah, so maybe I could show.
So what do we do if we want to see the log file of that Rails? app?
There's a way of copying the log file from the file system. There's a tutorial. I'll post the link in the Facebook group. It's quite lengthy, but there's a way of copying it from that remote file system to your
So
host.
inside that, somewhere here is an actual file that
File.
we can deal.
Could be, yeah. I think. Again, I'm new to this, so yeah. So I might be able to show if I have.
Font size, we can't see it.
This is a DigitalOcean slice that I just configured running the same Docker VM. So, sorry, yeah. So Docker, so Docker images. I have it. Oh, I have more. Docker. Run, detach, port.
This is digital.
Right.
That's a production environment.
Awesome. So I'm going to run the same image.
Provisioning.
And this is actually a demo. 6,000. So there is it. And that's my presentation. Thank you.
Magkano lazy?
Secret. May deal grocer, may deal. Kaya lang, CDR King yung laysang nila eh.
Hindi sabi yung meet.
just wait until this is as mature as VMware? Yeah.
That'd be nice, but you know, you can play it. You can play with it now, so why not? It doesn't aim to make all the tools that we're using obsolete. It aims to complement. So,
From the marketing, from
kinda.
your-
Yeah, so I know.
itself is a better VMware.
Understand.
How much are they paying you?
The pizza is for the